is equal to 1.2 d5, 1.2 d5, and limits at theta equal to pi by 4, phi is equal to pi by 2. Why? Because at theta equal to this, pi by 4 if I put, then phi equal to pi by 2. Theta equal to 0, phi is also 0. At theta equal to 0, phi is also 0. So limits, but this is 1.2. 1.2 has again come up. Okay, but it is the area of this function. This is limits 0 to pi by 2. A square, let me take outside, but no problem. This is cos phi d phi. This is 1.2. Now what about this? Sorry, this is cos, not a square, but only cos phi. This is only cos phi here. So a square, this is half a square. Let me take outside. And this is not cos square, but cos 2 phi. So this is, now we can integrate this as cos phi is, or this is single power 1 only. For 1 it is pi by 2 only. But let me put the value. This is sin phi. If I integrate this, I put the limit 0 to pi by 2 here. This is 1 only now. Because sin pi by 2 is 1. This is 1.2 a square. But if I make twice of this, because if this total area is calculated, then twice of this also give us only a square. So total area is a square only. Okay, of this whole area. So total area is equal to this is 1 only, because cos phi is indicated as sin phi, positive sin phi, and then put the upper limit pi by 2, it will give us 1, which is 1.2 a square, but this is area of one loop. Therefore, total area of the two loops of the curve, area of the curve twice into 1.2 a square, which is equal to a square only. So this is the answer. A square is the answer here. Okay. So area of the first curve we have calculated now. That is the first question we have done. Now, so far as this question is concerned. Okay, and this can also be calculated by double integral. We calculated this kind of question with the help of multiple integrals. In double integrals, we also calculated the same kind of question. And same answer, a square will be obtained, because this is total area. This is half a square, but total area of the two loops is a square only. So a square is the answer final. Now let me take question number second. Question number 2, second question let me take. Question number 2, what does it say? Question number 2, or second question, what does it say? Let me check. So here we are given that find the area of the cardioid r equal to a into 1 minus cos theta. So cardioid is this. The second question is area of the cardioid. The given cardioid is r is equal to, let me put the complete question. So this is r is equal to a into 1 minus cos theta. Okay, what kind of cardioid is the shape of the cardioid? We have to first find out. Then we will find out what is r square equal to a square into 1 minus cos theta. Also, we substitute that finally. We know that what is the area in case of curve. Okay, in this polar curves, area is half limits a to alpha to beta r square into d theta. Okay, that we will replace, and r square can be calculated from here. But before that, I have to trace the curve. That what is the shape of the curve here. Okay, so let me find the solution. Solution here. Here this again, if I put theta equal to minus theta, the curve is unchanged. because theta minus theta, but at minus r it is unchanged. Therefore, this is changed. But at theta minus theta, if I substitute, then this curve will not change because cos theta is even function. So cos minus theta is cos theta positive, so the curve will remain same. But theta, so the curve will be symmetric to the curve will be symmetric to the initial line. Okay, putting symmetric, the curve is symmetric to the curve is symmetric to the initial line. Curve is symmetric to the initial line as putting theta equal to minus theta, the curve does not change. The curve remains unchanged. Okay, so this is symmetric to the initial line. This is the basic point of curve tracing here. So we'll just find out what is the then shape of the curve. So at putting r equal to 0 or theta, if it is 0, then r is 0. Theta is 0, then r is 0. Then theta 0. This is 1 minus 1 because cos 1 is 0. So r is also 0. That is the initial point we will find out. Let me find out some points. So putting r equal to 0. That means 1 minus cos theta equal to 0 or cos theta is equal to 1. That means cos 0. Okay, so here theta equal to 0. Okay, I'm sorry, what I'm doing. This is cos 1, cos 0. Theta equal to 0 here because 1 is for cos 0. So here theta comes out to be 0 at r equal to 0. First point is 0, 0. That means this curve is meeting the initial line at this pole. Okay, the curve starts from here. Now if I take minus pi, if I put, so we will put theta angle from 0 to pi. If I take, so I'll take some points here and then let me take some table of the points. Putting theta equal to something, finding out r, what r comes out to be. If I put here 0, first I substitute theta 0. This is 1 minus 1, so r is also 0. Theta, if I put pi by 4, let me take pi by 4. This is, I'm not to take this pi by 4, let me take pi by 3 because it comes out to be then, let me take 30 difference. The difference of 60 degree. It is pi by 3. At pi by 3, it is 1.2, 1.2, 1.2, 1.2. This is a by 2, r is equal to. Then at pi by 2, it is 0. So this is a. At 2 pi by 3, okay, again it is with minus sign. So it will be 3a by 2. Because 1 plus 1.2. The cos will be negative value in second quadrant. Second quadrant negative, but negative is positive. So 1 plus 1.2 is 3 by 2. So it is 3a by 2. Okay, then let me take pi. At pi it is minus 1, so it is twice a. This kind of shape of the curve will be there. Okay, so let me take what kind of this curve is. This curve starts at like this. At 0, 0, it is 0, 0. And this is 0, 0 point. And here it is twice a distance. R is equal to twice a. Okay, at this point, this is theta equal to pi here. Theta equal to pi, here theta equal to 0. And here theta equal to pi by 2. Here it is pi by 3. 2 pi by 3. Okay, and this is pi. This kind of shape will be there. For negative values also lie in the below portion also. Okay, so this is the curve x-axis all here, initial line is symmetric to the initial line. This we have seen. What is the area here? For this area, we have to find out this area here. Okay, if I take r and theta, simple limits from 0 to pi. Here limits are 0 to pi. Okay, for this is initial strip we have taken. But what is total area? Area is twice of limits 0 to pi. Total area required, or area required, area of the curve required, or required curve, required area of the curve, area of the curve. What I'm doing, or required area of the curve, let me take. This is required area of the curve. The required area of the curve is equal to twice into, and take this is O point, this is A, let me take this is B point, OBA, twice into area OBA, twice into area OBA. That means twice 0 to pi, limits are 0 to pi, and this is r square, 1.2 be right, 1.2 r square d theta. We put this formula, this 2 to cancel out, nothing but 0 to, but yeah, this is r square 0 to pi. R square is a square into 1 minus cos theta whole square into d theta. Now this we have to solve here. Let me solve the equation. So this will give us, now squaring this, so here limits are 0 to pi, this 2 to cancel out, only 0 to pi, this is a square, because the whole square is a square also, and this a square we have taken outside, 1 minus cos theta whole square into d theta. Now let me open this 0 to pi. If I open this whole square, so what does it give us? This is 1 minus 2 cos theta plus cos square theta into d theta. This is the whole square of this. Now let me finally solve it. This is theta here, minus 2 sin theta. Now this let me separate. This is 0 to pi cos square theta, okay, d theta. This let me separate here, and this is 0 to pi limits here. Now for this is plus sign and plus a square also, or let me write this in this way: a square common throughout, bigger bracket, and this is theta minus 2 sin theta. Integration of cos theta is sin theta. So this let me take curly bracket, limits 0 to pi plus 0 to pi limits, and this is cos square theta. If I write cos square theta as 1 minus cos 2 theta, okay, or if I write twice of this, 0 to pi by 2, because if I make twice of this, an angle makes half, that will also give us the answer. Because if I write it as 0 to pi by 2 and twice of this, this is 0 to pi by 2 into cos square theta d theta, no problem. We can make half of the upper limit, or twice of the upper limit, half of the upper limit, and twice of this will give us the same formula. Or we can change cos square theta as this. So this is by reduction formula we can do this. Okay, so this is a square into this value. Now let me find out final answer. This is a square, theta is pi by pi only, minus 2 at both the cases, sin theta 0, sin pi 0, so this is 0, plus this twice cos square theta, and this 0 to pi by 2 limits. So it is 1.2 into pi by 2. This is the value of this one, this value cos square theta. When 2 is there, so 1.2 pi by 2. This value comes out to be, so 2, 1, 2 cancel out. It will give us a square into pi plus pi by 2. So this is 3 pi by 2. So 3 pi a square upon 2 is the answer. To answer this question, total area of this curve will give us 3 pi a square upon 2. So this is nothing but 3 pi a square upon 2. This area is. Okay, so this is the second question which we have done here. 3 pi a square upon 2. Alright, this is the answer here. Next, let me take question number. Let me change the marker. Question number now, third one. Okay, so this is the cardioid which we draw here. First we draw and then find out the area. So this is 3 pi by 2. 3 pi by 2 a square. 3 by 2 into pi a square, or 3 pi a square upon 2. That's the answer. Question number second we are done. Now let me talk about question number 3. Now, third question, which says, what kind of question is that? Let me check. Okay, question number 3 now. Now question number 3 is, find the area of the curve this. Now here r square is given. Directly we can find out the area. Okay. Question number 3 is, here directly r square is given. So find the area of the curve. So area of the curve, find the area of the curve. What is the curve here? R square is equal to a square cos square theta, so b square sin square theta. Okay, so here limits are, in the first quadrant we take the areas of this point and the area of the curve r square equal to a square cos square theta. But first we have to find out, putting r equal to 0, then cos square sin square theta equal to 0. So then we can find out what is the value of tan theta is a upon b plus minus a upon b. In that way we can draw this curve, but let me find the solution. Here r square is given to total area. We find out that area of the required curve, or required area of the curve, required area of the curve, required area of the curve here is, because this area will be 4 times in the 1/4 of the area. If we draw this area, okay, and this is symmetric about the initial line. Why? Because if I change the theta by minus theta, let me first think about symmetry. So required area of the curve is to be calculated. We will substitute this at alpha to beta. We will find the limit. What are those? But before that, this is r square d theta. But before that, let me think about symmetry. So first point is, the curve is symmetric. The curve is symmetric about the initial line. It's symmetric about initial line. As replacing theta by minus theta, it doesn't change. As and r equal to minus r also is not going to change, as theta initial line as well as the line which is perpendicular to the initial line. That means theta at theta equal to pi by 2 also, as theta equal to minus theta and r equal to minus r does not change. The curve does not change. The curve, or the equation of the curve does not change at putting r equal to minus r and theta equal to minus theta, the curve is symmetric of the initial line and to the line at theta equal to pi by 2 at or with the initial line. Theta equal to pi by 2 to initial line, to the initial line. Sorry, to the initial line. So the curve is symmetric to the initial line as well as the line which is at right angle or theta equal to pi by 2 to the initial line. Okay, so this line and this. So this curve will be symmetric to both initial line as well as the line which is perpendicular to the initial line. That is the point required here. Okay, so that point is to be noted down. Now next thing is that what is the area that, so the area of the curve is, and so, okay, so the limits of this area will be 0 to, it means if we have to find out area of this curve, so area of the curve is equal to 4 times area of it in the first quadrant. In the first quadrant, there are four quadrants. The curve will be in all the 4 quadrants. Area of it in the first quadrant. Okay, so and the limits will be from theta equal to 0 to theta equal to pi by 2. Limits are these in the first quadrant, 0 to pi by 2. And if I multiply it by 4, then it will give us the total area of the curve in all the 4 quadrants. This area equal to therefore 4 into 0 to pi by 2 into 1.2 into r square d theta. This is 1.2 r square d theta. We have substituted alpha here is 0 and beta is pi by 2. Because this curve is symmetric to the line 0 to pi by 2 as well as the initial line. Okay, so from theta equal to 0 to pi by 2 and r square d theta. So we have to, this is 2 to the 4, that means twice 0 to pi by 2. R square is a square into cos square theta plus b square sin square theta. Okay, into d theta, let me write in one form. So this is the value of r square. Now let me integrate it directly. So this will give us then the total area. So area is equal to twice, now it is because 4 into half is twice, 0 to pi by 2. First is a square, are taken outside, and this is cos square theta d theta, plus this is twice b square, 0 to pi by 2, this is sin square theta d theta. What does it give us? Twice a square. Now this is by reduction formula. 1.2 into pi by 2. This is also by reduction formula. The same formula applied for both. This is 1.2 into pi by 2 by or using by reduction formula or by reduction formula or using reduction formula. Okay, so by reduction formula we know this formula. This is 1 2 cancel out. This 1 2 cancel out. So pi upon 2, if I take common, this is a square plus b square. It is answer is 1 pi upon 2 outside, and this is a square plus b square is answer. Because pi upon 2. If I take common, it will be a square plus b square inside. So this is the area required answer. So pi upon 2, a square plus b square, the area of this whole curve. Okay, so this curve is symmetric to both initial line and the line which is perpendicular to the initial line, that means that theta equal to pi by 2. So limits we have taken 0 to pi by 2 and 4 times the area of it in first quadrant. The area in 4 quadrants, total area is there. So that is question number 3 here. Let me talk about question number 4. Question number 4, fourth question I mean, question fourth is, question number 4 or fourth question is of what kind? This is the fourth question. So show that the area of the lemma cone, okay, are equal to a plus b cos theta, where b is lesser than a. In that situation, is equal to pi a square plus half b square. Okay, this is question number 4. So lemma cone is given to us is r equal to a plus b, it is cos theta, where b is less than a, means a is greater than b here. A minus b is a positive value. Okay, so lemma cone is of this shape. Let me find out. Now in this case again, theta if I replace by minus theta, that curve does not change. Okay, so this is symmetric to the initial line. That this is initial line OS. So solution. The curve is symmetric about initial line, as putting theta equal to minus theta to minus theta, the curve does not change. It does not change. So the curve is symmetric to or symmetric about initial line. This is the initial line. Okay, draw the shape of the curve. Let me draw that shape of the curve now. Shape of the curve is of this kind. Here the curve is of this kind. Here this is a minus b, this distance from origin O, or this pole is 0, 0, and this distance is a minus b. Okay, and this is a plus b, and what are these lines here? I'll just draw them. This is a plus half b, a plus half b, or a plus half b, this value is, and this is a plus b here. This is suppose a point, this is b point, or this is O point here, or let me take a dash here, this is b point here. So twice of this area we have to find out. And what are the values of this theta? Okay, so from this, if I find out r equal to 0, if I substitute, that will give us the value here. Okay, so this r square equal to a plus b whole square, that you substitute. So a plus b, and theta is 0 to theta equal to pi here. Theta equal to 0 to theta equal to pi. This is theta 0 to theta equal to pi. 0 to theta equal to pi here. If I take from this point to this point, initial point, or from this to this is 0, it can be taken as pi. Okay, so this is 0 here, we can take, and this is pi here, or vice versa. But in this case, because this point starts from a minus b to this point up to a plus b. Okay, so if I take here theta 0, so limits are 0 to pi. Okay, and r square 1.2, 0 to pi, twice of this. So total area required, or required area. Okay, so required area of the curve is equal to twice into area. First let me take this area, twice into area. Let me take this a, b, and a dash, a, b, a dash. Or this is equal to twice limit 0 to pi. Okay, this is r 1.2, sorry, 1.2 into r square d theta. You substitute the same formula, 2 to cancel out here. This is 0 to pi r square is this value. This is a plus b cos theta whole square into d theta. Just 0 to pi here. Now let me solve it. So finally, what is the solution of this question? Let me take it. Okay, so this will give us, if I open this whole square, so it will give us, let me first open 0 to pi limits, a square plus b square cos square theta plus twice ab cos theta. Okay, and the limits here we will substitute, but before that let me integrate this. So it will give us a square theta, limits 0 to pi, let me separate this, plus this is b square 0 to pi, and this is cos square theta into d theta, plus this will be twice ab integration 0 to pi, it is cos theta d theta. Okay, now in this case, if I change this limit 0 to pi by 2, it is twice of this will be, let me write this answer here. So final answer will be, first is a square into theta, when I put the limit, upper limit, it is pi here, at 0 to 0, plus this value will give us twice b square. Okay, this is 0 to pi by 2 now, it is cos square theta. Now we can apply the reduction formula here. This is twice ab into sin theta integration 0 to pi at both limits, sorry, 0 to pi at both limits 0 and pi, this sin theta is 0, so this value is 0. So what we have, a square pi plus, now this is twice b square into, by reduction formula, cos square theta in 1.2 into pi by 2, 1 to cancel out, it is nothing but a square pi plus half pi b square. If I take pi common, yeah, it will give us a square plus half b square. This is the final answer. The answer of this question is pi into a square plus half b square is the answer of question number 4th. Okay, question number 4th we have done here. So half of pi into a square plus half b square. Okay, so that is the question number 4.